Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to be going through question number 2 from the February-March 2023 paper 4 variant 2 from the Cambridge 0580 IGCSE series. And this question here is a question that's all about statistics and frequency tables. So the first part is about a normal frequency table, then you have group frequency tables, histograms. So there's a lot of statistic stuff here, which I'm going to go through this question, which is very important. Now, the first question, 2 part A, says 100 students take part in a reaction test. The table shows the results. The reaction time in seconds, you've got 6, 7, 8, 9, 10, 11. And the number of students who had those reaction times are given as 3, 32, 19, 29, 11, and 6. Write down the mode. Now, many people, they don't understand what a frequency table actually is. They have no idea what it is, and they just do some weird kind of guessing as to how to write down the median, the mode, and so on. Okay, and you know that can become a big problem. So what you have to do is you have to try to understand what is a frequency table. Where does it come from? How did somebody get this frequency table? Right. So they tested 100 students. So the number of students that have been surveyed or have been, in the survey is 100. There's 100 entries. Okay. And this number of students is like the frequency. This is the number of students. Okay, we can call it F. And this is X, which is the time that they had, their reaction time. So the data would consist of the numbers 6, 7, 8, 9, 10, 11. Okay, and the frequency, the number of students will tell you how many times those pieces of data appeared, okay, in the list. So if you were to replicate the original raw data that somebody might have got when they compiled or before they made the frequency table, in their data they would have 3 6s. So you'd have 6, 6, and 6, and they'd have 32 7s. So they'd have written down 7. I'm not going to write it down that many times. Altogether 32 times. So there would be altogether 32 7s in the data. Okay, and they'll have 19 8s. So they'll write 8, 8, 8, 19 times. There'll be 19 8s in our data. And so on, 29 9s and 11 10s and 6 11s. So the data, the raw data would look like this. So if they say write down the mode is a number which appeared the most frequently in the data, and we can see that it must be the number 7. Because it appeared 32 times. 7 appeared 32 times. No other number appeared more than 32 times. So 7 is the mode. If there was another number that appeared also 32 times, then you'd write that number and 7. Okay, you'd write them both down. Okay, for example, if 9 appeared 32 times as well, you say the mode is 7 and 9. Okay, the median is a number in the middle when they're written in order of size. Now, many people think, the median is found by looking at the middle between 6, 7, 8, 9, and 10, 11. But that's not correct, because you have, different numbers of each of them. Okay, so the median won't be found by just looking at what's in between these. In that case, it would be like 8.5. Okay, that's not how you do it. All right, you have to. It might be close to 8.5, but that's not how you do it. Okay, so you have to be understand first of all what is the median. Now, the median is a number that's in the middle when the numbers are written in order of size. There are 100 numbers in the data, so the median is found by taking 100, dividing it by 2. Well, that gives us 50. Now, if the number comes out as a whole number, then there's different ways of dealing with this, but the way I like to do it is you round up to the next term. So if it comes out to a whole number, that means there's 2 middle terms. So you have the 50th and the 51st term. If it comes out as a whole number, you take that term and that position and the next position. So we're looking for the number that is in the 50th position and the 51st position, and those two numbers, when we find them, we find the average of those two. Okay, you round up to the next number if it was that you ended up with a decimal. Basically, when you have an even number of entries, supposing you have like an even number of entries, okay, supposing you have, for example, 6 entries, then there's not one number in the middle, there's 2 numbers in the middle. Okay, but you have an odd number of entries, there's 1 number in the middle. So when you have an odd number of entries, then you divide by 2, you get something 0.5, you round up to the next number. So there's 5 entries, divide by 2, you get 2.5. The third entry is what you're looking for. But if you have 6 entries, you divide by 2, you get 3. You're looking for the third and the fourth entry. So this is just on a bigger scale here. We have 100 entries. So basically, whenever you have an even number of entries, you'll always have two middle terms. When you have an odd number of entries, you'll always have, one middle term. So to find the middle, what position that the middle term is in, you take the number of entries and divide by 2. If it comes out as a whole number, you take that entry and the one after it. If it comes out as a decimal, you take, you round up to the next number, always round up, and you take that number that comes there, that term that comes in. So now, 50 and 51 are not the median term, they're not the median values, they're the positions of where the median terms are. Okay, so that's very important for you to understand. So you can see here that there are 3 numbers which are 6. The next 32 numbers are 7. So by the time you've got to the last 7, you're on the 35th number. We're looking for the 50th number and the 51st. There's 19 numbers, they're all 8. So when I find the next 19 numbers, the next 19 numbers will all be 8. So if it was 20 numbers, that would be 55. So that's going to be 54. Okay? So the 54th number is an 8. That means the 50th number is 8 and the 51st number is an 8. Therefore, the median is 8. The average of those two is 8. Okay? So that's how you deal with finding the median. All right? Calculate the mean. Now, the mean is found by basically adding together all the entries and dividing by how many entries there are. All right? Now, I know that there are 200 entries altogether. Okay? Why? Because they told us. 100 entries altogether. Okay, 100, because they told us. Why did I say 200? I don't know. 100 entries altogether because they told us. We don't have to actually count. If we were to count the number of students here, if you added these together, it would give us 100. That's the number of entries in the data. There's 100. Okay? We have to find the sum of all those numbers. How do we find the sum of all those numbers? Well, as we were thinking about before, you have 3 numbers. All of them are 6. 6, 6, and 6. If you add them together, you're going to get 3 times 6. And you have 32 numbers, all of them are 7. Okay? If I want to add all those 32 numbers together, all those 32 7s together, I'll have to do 32 times 7. So basically what we need to do is we need to find f times x. We need to multiply the frequency by the number of, we need to find the frequency with the number of students by the reaction time. So we can say 3 students had a reaction time of 16. The total of those times, those 3 6s is 18. 32 students had reaction times of 7. The sum of those 32 reaction times is 32 times 7. So we can do 32 times 7, which gives us 224. Okay? So we can do this in a quick way by not having to write them separately. We can just say, okay, we'll do 6 times 3 plus 7 times 32 plus 8 times 19 plus 9 times 29 plus 10 times 11 plus 11 times 6. All of that over the number of entries altogether, which is 100. And that will give us our mean. Okay, so we can just stick that in the calculator and just be very careful not to make any mistakes. So 6 times 3 plus 7 times 32 plus, I'm going to double check with the table in case I wrote something down wrong, 8 times 19 plus 9 times 29, 9 times 29 plus 10 times 11 plus, and finally 11 times 6. Okay, and that gives us, and divide by 100, and that gives us 831 over 100, 831 over 100, which is 8.31. 8.31. Now, if your mean, mode, and median were numbers which are completely different from these numbers, it wasn't somewhere between these numbers 6 to 11, then you know you've done something wrong. But how we've got the mode as 7, the median as 8, and the mean as 8.31, and all of them are kind of like sensible. They're in between these values, somewhere in the middle of these values. Okay, so if, for example, you got the mean as 20.2, or the median as something weird, so you'll know you've done something wrong. Okay, they have to be somewhere in these, because the mode and median and mean are values which are supposed to be like telling you what the middle of the data is. There are different ways of showing the average. Okay, so they should be somewhere in the middle of the data. Okay, depending on how it's distributed. Like if there's a lot more data on this side, then it will be the median will be more to this side. If there's a lot more data on that side, the median will be more to that side, so on. All right, so now, part 5, it says, 2 students are chosen at random. Find the probability that their reaction times are greater than or equal to 9 seconds. All right, greater than or equal to 9 seconds means, okay, it's these, 9 seconds or more. So the probability that the 2 students, both of them, have a reaction time greater than or equal to 9 seconds. So we've got 2 students. So one of them, okay, so both of them are greater than or equal to 9. So the first one, you're going to have, to add all these together, you're going to have 29 plus 11 plus 6. Okay, so it's going to be 29 plus 11 plus 6. Let's write that down over here. The sum of those is going to be, that's 29 plus 11, that's 40 plus 6, 46. Okay, is that correct? 17 plus 29, that's 37, 46. Yes, that's right. So you have you got 46 over 100 for the first one, and the second one, here's the reaction time, also has to be greater than or equal to 9 seconds. Now there's 99 students remaining out of the 100 because you've taken one already who had a reaction time greater than 9, and you've got one less student also who's got a reaction greater than 9. So it's 46 over 100 times 45 over 99. So that's going to give us, let's have a look, 46 over 100 multiplied by 45 over 99. So that gives us 23 over 110, 23 over 110. Okay, you can write it as a decimal, you can write it as a fraction, that's fine. Okay, so there's part 4. Then it says part B says the box and whisker plot shows the heights of some students. Find the range. Now the range is basically simply the difference between the highest and the lowest entry. So the box and whisker plot has different bits of information. It tells us the lowest value. It tells us the highest value in the data. It tells us the median. It tells us the lower quartile. It tells us the upper quartile. Those are the different pieces of information we can derive from the box and whisker plot. Okay, the median is the number in the middle. The lower quartile is a number which is a quarter of the way into the data. The upper quartile is the one which is 3/4 of the way into the data, such that it's bigger than 3/4 of all the data. Okay, and then you have the lower value and the high value. So the range is a difference between the highest value, which is over here, and the lowest value, which is over here. So you got here 150, that's 160. Each of those is 1. That's going to be 158. Okay, so you have 158 minus the lowest value, which is 105. Okay, so if you subtract them, you're going to get 100 and you're going to get 53, not 100, 53. Okay, 158 minus 105 is 53. And now to find the interquartile range. Now, what is the interquartile range? The interquartile range is the difference between what's called the upper quartile minus the lower quartile. Upper quartile is sometimes known as Q3 and lower quartile Q1. The median is known as Q2. So this would be the lower quartile, which is the beginning of the box, and the upper quartile Q3 would be the end of the box. So that is like the middle 50% of the data is contained there. That's 25% of the data, the lowest 25%. Then from there to there is 50% of the data from the median and backwards. Yeah, that's such that it's higher than 50% of the data. That's Q3, which is the upper quartile, is such that it's in a position where its value is higher than 3/4 or 75% of the data. Right, so the difference between the upper quartile and the lower quartile is called the interquartile range. So the upper quartile is going to be given by this value over here. So this is 140, and each of these is worth 1, so that's 142 minus, and the lower quartile is going to be this value over here, which is 122. So the answer here is 20 centimeters. That is the interquartile range, okay, of this data. It's like tells you how spread out the data is in the middle 50% of the data. Next, we've got here to calculate an estimate of the mean of this data. Now, this is very much different from the data that we have here. In this case, So in this case here, we know exactly what data entries we have. We know how many 6s there are, how many 7s there are, how many 8s there are, how many 9s there are. We know we can write down every single piece of data that was there in the original raw data that we collected, okay, before we made the table. We can bring the data back from the table. In this case, we have what's called a group frequency table. So somebody has measured the mass of these 200 potatoes, and they haven't written down like the frequency table as like individual masses, because it probably didn't make sense to have so many different categories. So what they did is they said, okay, let's group the masses together. So all the potatoes who had a mass between 50 and 110 grams, we will clump them together in this group, first group here. All the ones who had masses over 110 up to 200 in this group over here, and all those potatoes had a mass greater than 200 up to 300 in this group here. So I know there's 60 potatoes with a mass somewhere between these values. I do not know what those masses are. I know there's 99 potatoes somewhere between these values. Their mass is somewhere between 110 and 200. As for each individual potato, I don't know what its mass was. So I can't write down a list of all the masses of all the potatoes. So that's why the question says calculate an estimate of the mean. Because you cannot calculate the mean, you don't have enough information. We don't know what the actual data values are. So to calculate an estimate of the mean, the best thing we can do is we can take what's called the mid-interval value. So this is our frequency. We can't use this as x now. I'm going to write the x up here. X is the mid-interval value, the number halfway between these two values. To do that, to find that, you just simply add them together and divide by 2. That's 160 divided by 2, which is 80. So that's the number I'm going to use. So I'm going to assume all 60 of these potatoes were 80 grams. That's the best we can do. All right, so we'll have 60 times 80 plus, and then these 99 potatoes. So you have 99 times what number? Well, we do 110 plus 200 divided by 2. That's going to be 310 divided by 2, which is 155. Okay, and these, you got 200 plus 300 divided by 2, which of course is 250. So here 99 times 155 plus 41 times 250. This is an estimate of the sum of the masses of all the potatoes. To find the mean, we have to divide by the number of potatoes, which we know is 200. Okay, so we divide by 200, and that will give us our answer. So we take 60 times 80. 60, and be very careful not to make a mistake. Very easy to make a mistake. Plus 99 times 155. Always check what you put in your calculator. Okay, it's the same. 99 times 155 plus, and we got 41 times 250. 41 times 250 divided by 200. And that gives us 6079 over 40. Okay, which is 151.975. That gives us 151.975. Now, how do I write this answer? Well, this is like an exact answer. So we can leave it as 151.975, and there's no problem with that. You don't have to round it to 3SF because this is an exact answer. If you were to round it to 3SF and write 152, they would probably be okay about it. But because it's an exact answer, really you should write it to 3SF. You should write it as it is. Because it stops there, it's an exact answer, leave it as it is. That's better. Okay, so there's number 1, part 1 of C. Part 2, which is the final part, is about this histogram. So here we have a histogram, which we want to complete using the information in the table, which I have copied down here so that we don't have to keep scrolling up and down. So in this table here, we have the mass, okay, against the frequency as above, all right? But we have to now complete this histogram from this table, okay? So the first bar has been drawn. So we can see it's from 50 to 110, and it goes up to frequency density of 1. So frequency density basically is equal to, frequency density is the frequency divided by the interval. So here we see 60 divided by 60, which is 1. That's why that goes up to 1. And here we're going to have the difference here is 90 divided by 99. This is going to be 99 divided by 90, because it's frequency divided by mass, by the interval. So it's going to be 99 divided by 90. Okay, 99 divided by 90, which gives you, I think, 1.1, 1.1, 11 over 10, which is 1.1. So the frequency density must be 1.1. And for the last, it's going to be 41 divided by 100, which we know is 0.41. Move back 2 spaces, so 0.41. So those are the frequency densities, and that's what I have to plot. So 1.1 is how high this goes. Now this is, as you can see, that's going to be 1.1, 1.2, 1.3, 1.4, 1.5. So 1.1 is 2 squares above 1, 2 small squares. So we can draw that. Okay, so from there up to 200. Up to 200. So I can go up to 200. So let me complete this and this. All right, so that's the first part, up to 1.1. And the second one goes up to 0.41 all the way to 300. So 0.4, that's 0.5, that's 0.4. So 0.4 is going to be somewhere here. So it's slightly above 0.4. So it's slightly above it. I'll do it like that. And we'll finish it off. So that is our frequency. That is our histogram. Slightly above, slightly to the right. Okay, so it's okay, it's not too bad. So that's our histogram. Okay, so those are the frequency densities. Those are what we plot. A histogram, sorry, a histogram displays the data in such a way that the area is proportional to the frequency rather than the height, and it makes the bars in terms of the area look in proportion with the frequency. So there we have the end of this question number 2. Okay, other questions from this particular paper can be found in the playlist that will appear at the top of the page for here at the end of the video. Other questions from the topic of statistics from IGCSE can be found here. I'll put something dealing with frequency tables and calculations over here and histograms over there, so you can look at different questions on those particular topics in statistics. I hope that was clear. Thank you for watching, and see you soon.